Good morning, and I really appreciate hearing what Janet had to say this morning. That was very enlightening, as usual. I always get whenever people come to me up at church and they say, "Well, what do you do what do you do at Duke? What do you do for a living?" And I'm like, I always give them a warning up front. I'm like, well, if you ask me, and I have to tell you, I will put you to sleep because I really like talking about Mercury. So, and it'll bore the, you know, what out of them. But so I've been involved in Mercury for quite a while, even back before it was popular. Uh, but it's been a long road. It's been very interesting. I've had opportunity to do a lot of testing, characterize our units, uh, doing a lot of, with the EPA ICR. They were helpful to understand what our emissions are like and how we got to deal with it. At Duke, we've been blessed to do a lot of testing, work with DOE, EPRI, other utilities to figure out what we have. And so the presentation today is just kind of a summary of what we're doing at Duke Energy to manage our mercury control. That's what I've been working on for the past several years. So, and a lot of this stuff you guys know, but it's some basic parts about mercury, but we're utilizing the SCR for oxidation, our scrubber to remove soluble mercury, and then we also have our ESPs. We've got one bag house, a unit where we will inject carbon. So it's these three areas are our focus for really getting the bulk of the mercury out of the flue gas, so it doesn't go up the stack. We utilize coal additives. The Nalco 7895 is a calcium bromide product. That's to enhance the oxidation. Sorbent injection or pack. If you can see here on the, see if I can get this thing, just where it's difficult to point here. Upstream of the ESP, and then scrubber additives for re-emissions control. So at Duke, the mercury re-emissions was an issue that popped up really unexpectedly. When I was doing a test at one of our units, I had 4 carbon suppliers coming in. We're injecting carbon upstream of the precip. You're going from 6 micrograms down to about 1.5 out on the exit of the precip, and then at the stack, boom, you're back to 4 to 5 micrograms, and driving the carbon guys nuts. They're like, what's going on? We're not getting the mercury out. And that was when we first discovered re-emissions. I'm like, so I talked with Chuck Dean at EPRI and Gary Blythe, the URS at the time, and they were trying to track down this it's elusive Sasquatch that's called mercury emissions, because it pops up all over the place. It's like an animal. You're trying to trap it. But once we understood we have that and we've seen it, and you do enough testing to realize that it is real. So we were working with Nalco, who has a product, they're 8034 plus, and since then we've installed like 13 systems after doing a lot of testing, a lot of vetting, balance of plant measurements, just to make sure this stuff is safe and it doesn't cause other issues. And pretty much settled in working with Nalco on that, as well as their 7895. So we've got 7 units using that. And as much as I'd like to use more powder-activated carbon, because I'm a mercury geek, but we only really have 5 units that use carbon. And it's only because carbon works. I mean, you put it in, the mercury goes down, it works. So this is just some data we're seeing. I'll spend a little bit of time about mercury emissions. A lot of people just didn't understand that it existed. And I think after MATS came along and people started putting SIMs on the stacks, and they realized, you're starting to see some high numbers at times, where other times it's low and then all of a sudden it shoots up. What's going on? We see that. And you can see here, I'm losing my voice, but that gap right there, it's basically the mercury that comes into the scrubber. It's going to be either oxidized or elemental, and the wet scrubber is going to take out the soluble fraction. So if you got 80% soluble coming in, you're going to get 80% removal across the scrubber. And then that other 20%, elemental is going to go out the stack. So what you see is if you've got that 2 micrograms or 0.5 micrograms of elemental coming in, and all of a sudden you're seeing 4 go out the stack, that's reemissions. Something's going on in the scrubber. The soluble fraction is reducing back, and then it's going out as elemental mercury. And you can see here, I mean, it'll pop up. It's not necessarily load related. It's the biggest, or the best analogy I use is this is a 1,000,000-gallon titration. And the only thing I got out of college chemistry was orange, 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 red, right? That stuck with me. And this is the deal with this reemissions. There's some cycling up that takes place that it triggers the reemissions. When did it start? When did you start orange, orange? The day before, 2 hours before, weeks before? What caused it? The coal's changing every day. What changes in the coal? We can see the sulfur. We have that SO2 inlet. Well, the SO2 inlet may not change, but the chlorides may, the iron may, the mercury may. We're not measuring that. So you see a lot of things are going on. It's difficult to track. And then all of a sudden it may, like you see here, it may just come back together again. And this is the way it does that we've seen on a lot of our units. You guys may have also, I'm not sure, but it's somewhat site specific, it's coal specific, it's the type of scrubber specific. So the industry is still trying to figure out what causes this, how can we do it. I know Chuck Dean, Gary Blythe, you may have been working with them, trying to adjust oxidation air, change pH, do something. All these come at a cost that are not normal to the scrubber operation. So we're kind of blessed that we're able to, at least we recognize the problem. We can put a chemical in, and it will take care of the issue for us. There it is. Just another data piece here that shows. I've been on site a couple times, and it happens right before your eyes, several times. You run to the scrubber control room. What did you do? What did you do? They're eating lunch. They didn't do nothing, and it literally changes before your eyes. And some of the correlations we have here, ORP is a good footprint of this Sasquatch that we're trying to trap. If ORP is high, anywhere above 350, we see the opportunity that it's probably going to re-emit. And so if you can drop your ORP down, the mercury will come down with it most of the time. It's pretty solid that takes place. That we can measure, but we have ORP instrumentation on our scrubbers, so you can see that and use that as a process variable. The other thing that changes is the soluble mercury content will increase, and it may go from, like it is here, about 190,000 ppt down to 0. And that's only measurement analysis after the fact. But if you think you've got it going on, and I get these phone calls probably once a month from the plants that go on, we think we're re-emitting. I'm like, grab a scrubber sample, get a sample, get a sample. At least we'll find out later on that, yes, that was it. So we see evidence that it's taking place. But if you notice the blue line going up, that's the mercury in the solids goes from a low level to a high level. And then the soluble mercury will go from, and that's I think it's the light blue line, but it drops down to nearly 0 or less than 1,000 ppt. Then you know you're pretty good on soluble mercury. And also the ORP will drop just like it's done here. This is I love this graph. It shows everything all at once taking place. And at the same time, the mercury in the coal was increasing. So it's just, something else going on that's not an instantaneous process. There it is. So at least we've, just been able to discover this absorber ORP, oxidation reduction potential. I'm not a scrubber person, but I do know we can measure it. And when it's high, mercury's high. When it drops, the mercury emissions will drop as well. And you see that in this slide here. And it breaks quickly. I mean, it doesn't take its time. Sometimes it does, but we've seen big changes fast. And again, here, this is similar to that other slide I showed earlier, but it also, you can see that it changes regardless of unit load. And the brown line there is the ORP decreasing, and then the stacked mercury comes down with it. So it's kind of at least good to know you can see some other signs to try to control that. So we did a lot of testing, spent a lot of money working with NALCO. This is a problem we absolutely had to solve. You can't just live with 4 to 6 pounds per trillion coming out the stack. And even downstream of activated carbon. So we're fortunate, spent a lot of time working with them, and got this to work. And you can see this slide shows the soluble mercury. The blue line across the top is a sister unit that was not treated, and that's somewhere probably around 100,000 ppt of soluble mercury. And when we turn the chemical on, you can see the green line was a treated unit. It drops down, and then your percent mercury emissions does also. So the chemical works. So now we've got all these systems installed. What I've been working on now is getting the operators trained, recognize, okay, we've got a new emissions limit we've got to manage to. It's called mercury. It's very similar to dealing with opacity in that you've got some controls you can deal with. It's an average number you have to manage to. So again, this slide shows an event that took place. We were running somewhere around 0.2 or on pounds per trillion. The ORP's right in a sweet spot, about 185. It takes off, it goes up. Stacked mercury goes with it. And you can see it drops down regardless of load. Even the unit load was the same. It's almost like a battery. It charges and it discharges. So it's like it's discharged, but it didn't go back to the 0.2. So the operators recognize this. They turn on the NALCO system. Unfortunately, they did it in reverse order, which is why we got to train them. They put on the smaller dose pumps. It took care of a little bit of the ORP started down a little bit, the red line there, and then they turn on the slug pump, which is about 60 times the feed rate. You turn it on, boom, within an hour or so, you can see the red line, it drops. So the ORP drops, the mercury comes down, and we're back to 0.2 again. The difficult part is knowing when to turn the chemical off. So they'll run the slug pump, turn it off, and then you got to wait. I mean, you knock this thing in the head, it's down, but you kind of got to wait. And it may creep back up over the next several days. It depends on what was driving the ORP. So, you may have to rinse and repeat, do this process again. So they have the means to what I've been telling them to do, hit it with a slug pump, and then come in with the dose pumps and kind of do a low feed rate to manage it. At some point, you can turn it off and just kind of wait and see what happens. And that'll work too. But we got a ways to go training these guys. Just another instance where we had, again, they utilized the slug pump for a couple hours there, turned it on, ORP drops, mercury drops. So basically that's our re-emissions control, and it's 13 systems. We have one unit that's just consistently re-emitting and still trying to figure out why. But we have these other units that pop up every now and then. And on the average, with the mercury averaging, you can manage those spikes, but if you get a lot of them, all of a sudden you can't handle 6 pounds per trillion when the limit's 1, too many. So that's why we've got the systems in, got to train the operators to do exactly like I was telling earlier, hit it hard with a slug pump and then manage it with a dose. So that's our re-emissions. So just some kind of a show and tell on our tanks. They're fiberglass tanks, 15,000 gallons with containment. And the pump skids, if it'll go, there's pump skids, pretty simple. Just some chemical dose pumps and either air-operated or electric slug pump. Just basically a 4x4 skid. So it's not a huge capital investment. Okay, now switch gears. I only got 30 minutes, but Nalco 7895. That's a gentleman there from Joe Grom, or Great Lakes, talked yesterday. This stuff works. It's amazing how well it works. It oxidizes the mercury. And we found that we really did need it on one of our units. So let me see. So this is, again, some testing we did. Originally, this is a couple years ago, everyone thought you had to put the, you would put the calcium bromide on the coal going up into the bunkers. I really am not a fan of that. I like it going right on the coal belt. You don't have to wait 24 to 30 hours to see it work. So we have it going right onto the mill feeders. And our first test was, we were putting it on all the mill feeders, like 5 mills to get into the furnace. And we were basically at where we're at now. During that test, we're like 4 times the base feed that we're doing now. And you can see you turn it on, and I mean, it drops mercury. It's amazing. You're putting a chemical on such a little amount on the coal belt. It goes through the boiler, it goes through the SCR, it goes through the ESP, it goes through the scrubber. It gets out of the stack in less than 5 minutes. This stuff is, I'm still amazed by that. But you turn it off, boom, it goes back up. You don't have to wait. So, it's kind of like I mentioned yesterday at the table. When you're optimizing, you start really high, and then you start turning down till it stops, and then you go back up a notch. But so we were able to go to 2 mills with about 2 times our base. So we just turn it down again. We go to feeding it at 2 mills. You really only need it in 1 mill just to get it into the furnace. And we're down at our base feed, which is about half of this other. And it's very, very low feed amount. And it still works really well, because you can see when we turn it off, mercury will jump back up to about 2.3. So this particular unit, it really works. What we found is, especially on an SCR unit, and this unit was handicapped by its high flue gas temperature. So if you don't know, the SCR guys know this, and y'all may also, but mercury oxidation across the SCR at high flue gas temperatures, somewhere around 700, 730, you get less mercury oxidation. So we have a unit that runs some of those higher flue gas temps, and so their SCR was not getting the oxidation they need. And so we tried this chemical on that unit, which theoretically should not need calcium bromide. And amazingly, it's worked as well as it has for us. Again, some poly tanks, fiberglass tanks. We got a bulk receiving tank, and then they've got small day tanks up at each mill feeder. There's 4 units. And that's just where we inject it on top of the mill feeders. Really, it's not that complicated. It's just tubing and some solenoid valves. Okay, well, I'll switch gears to the third control technology, and that's powder activated carbon. And if you're really familiar, I mean, at our units, we can make our own carbon. It's called LOI, loss of ignition, and it's when your ash turns from a nice gray to darker. That means you're not burning it completely. When you fire for NOx, basically. But so you can make your own, but it's more equivalent to the surface area of a golf ball. This slide's been out for years, and I think it's a really good comparison. LOI or carbon that we make in the boiler is like the surface area of a golf ball. If you use the activated carbon, it's the surface area is like a sponge. It's got so much capacity to capture mercury. And so if we've got a few units that have a lot of golf balls, and their ash is pretty dark, but still, you want to clean that up. And then if you have to use mercury control, you want to try it with activated carbon. It has so much more capacity. So this is something I tell our sourcing people and the guys at the plants, is not all carbons are the same. This isn't a commodity like urea. It's not limestone. It's not anhydrous ammonia. It's a engineered product, and I've done several side-by-side tests with carbons, and you can see that the performance is not the same across the board. And I always try to line up the feed rates just to get this type of data. So there are differences in the carbons, and you're looking for that, cheapest dollar for best performance. So if you can do some of these tests to learn that, it helps you make a good decision. And another interesting aspect, I know DOE did a lot of testing, and everyone's probably seen the slides that SO3 has a negative impact. We heard it yesterday. It's just a fact of life on activated carbon. But it's always good to, on your plant, you see this theory in action. So I set up a test. We were doing some testing on this unit. 6-pound sulfur coal, it's pretty high sulfur. And I told the guys with the carbon, I said, this is a reality for us. You do have about a 1-second residence time ahead of the precip. It's eastern bituminous coal. And we were supposed to burn that 6-pound coal for about 3 weeks. Well, they started running out. And as they start running out, you can kind of see the red line down at the bottom is the percent mercury removal. At the higher sulfur, and these are all the same feed rates, the higher sulfur coal, the 6-pound coal, you didn't get as much mercury removal. And then as the coal started dropping, the percentage starts increasing. So basically, lower sulfur coal, you're going to get, you don't need as much carbon. That's the bottom line. So if you're going to burn higher sulfur coal, you're just actually going to have to use more carbon. But also be aware it does level out. I mean, I think we all know that. You can put so much in that it will level out. Where the more you do, it won't necessarily help you. So again, these are just some slides about the equipment now we have installed now. It's been a long road to get this up and running. Had some issues with some design, and but we got those worked out. That's our silo and the truck unloading. And then the other slide here shows the lance. We had to put some steel in to get the lances and the valves for the hoses. So we're just getting this equipment up and running. We did have an extension, so it's what's taken us into this year. Some of the issues we had, some of the design, there's something called the saltation velocity through those 4-inch pipe when you're feeding carbon. That velocity has to be up and high enough so the carbon doesn't lay out in the lines. And we had some really long feed lines, 300, 400, 500 feet, and some high feed rates. So we were getting some puffing back, and you don't want carbon in the silo like you see here. I mean, it was pretty rough. So I'm like, well, maybe when they built it, somebody left a rag in the pipe, during installation. So we took all the pipe apart, trying to troubleshoot, ran a borescope through just to see, and that was interesting. That's just a cool picture. That's why I put it up here. But we didn't find a rag. What we found is the system needed to be somewhat redesigned. So we got that issue solved, and this is just another picture now. We've got an eductor and a blower, and we are actually running, the middle picture shows feed rate of 1,500 pounds an hour. We ran there for 8 hours, so it was a success, no problems. And then you recognize that distributor, that's a United Conveyor type distributor that we're using. And I know when I say 1,500 pounds an hour, all the carbon guys, they start salivating, that's like, yeah, that's a lot, yeah. But we had to test high. This is on non-brominated carbon. I wanted to see what it would do like on the lowest performing carbon. So that's what we used during commissioning. And this is about 2 weeks ago data. You can see that the mercury was coming up with unit load, and we turned on the 2 feeders. This is during some operator training or some commissioning we were doing. And definitely the mercury drops. That's about a 40% removal. So again, I like it when you turn it on, the stuff works. You turn it off, and it creeps back up. So it makes you feel good that you made a right decision. This is some big dollars for spending. So it's just satisfaction to know that what you've installed is working. So now we're to the point now we're getting the operators trained, getting them to understand how to use the equipment so we don't over-inject, because like I said, you can over-inject and more doesn't make it better necessarily. Same with calcium bromide. Like I said, you get a saturation point where there's only so much mercury that you're actually taking out. But some of our challenges, this is the last slide, is of course coal quality variability. We got one unit, they'll burn 6-pound coal one day and 3-pound the next, so that's swinging. And so it causes some things you have to be aware of. It'll have an impact on mercury emissions. It has an impact on the pack injection, powder activated carbon injection. We were injecting 12 feet downstream of an SO3 flue gas conditioning system because this unit had a cold side precip that needed it. It's the worst place we could ever inject, but that's where we had to inject. And there's some sulfur resistant carbons, sorbents out there now that can manage that. Flue gas temperatures make a difference. One of our units, this real quick, is they noticed that they're having trouble keeping their mercury down even with their SCR, and what they discovered was if they started blowing their SCR more, what they were running into is their flue gas temperature was hitting that 700 degrees. So if you blow your boiler, temperature is going to go down. Temperature went down, oxidation went up, mercury goes down. So that's just another part of learning that we have to do operationally to learn. It's blowing your boiler makes a difference on mercury, and all this stuff eventually fits together. I also noticed that sometimes if you add DSI, hydrated lime or whatever for SO3, is it will take out, it's a two-edged sword. It'll help the activated carbon, but it does take out HCl, which can be a negative hit on your oxidation for the mercuric chloride. So that's another balance you have to deal with. We finally got where I can feel like I trust our mercury sims. If that number's no good, you could be chasing your tail on bad data. So mercury goes up, I always ask the guys, do you believe the number? If you think it's real, it's right, okay, then we start reacting to control it. Same with the ORP. We're using ORP as a process variable for control of the re-emissions. So that's got to be a good number. I know a case where in automatic, chemical started chasing a bad ORP input, and that's dollars per hour that you're wasting on bad data. So maintaining those instruments and then getting operators trained up. That's our focus now. So that's all I got for the presentation. Yes. Sorry about my voice, it's crackling.
I'm from wastewater field, okay? So do you have an incinerator to recycle your activated carbon? Because we've used that, do you?
No, they've talked about that, and the downside of 1,500 pounds an hour, if I brought the ash samples, you'd definitely see brown ash, no carbon, activated carbon, and black ash at 1,500 pounds an hour. So there's been some discussion about carbon burnout to clean that up. And what I keep telling the guys, I said, yeah, you can do that, I'm sure it works, but you understand the one way to get the mercury out of the carbon is to heat it up. So if you go burning ash that's got mercury, that's got carbon, or carbon that has mercury, you're going to release the mercury. So you have to be aware that if you do that to try to burn that out, that's one way, the only way I know of to get the mercury out of the carbon. Otherwise, it passes the leachate test. DOE has all that data. But if you do heat it up, that's how you release it. So we don't have that, but that's what I keep cautioning our guys.
Well, I feel like we had a similar situation because we were polishing water before it went to the river, and we were getting, we were picking up with all that extra surface area on the carbon. We were picking up a lot of different material.
Yeah.
Yeah, we did release it, We also further expanded it in the incinerator. I can give you a contact if you want to talk to somebody about activated and how you can recycle it. I don't know whether that's doable or not.
Yeah, I don't know. Right now, we're working because of the ELG and the CCR rules, and Brandon and these other teammates here could talk better about that, but with our dry landfill, we're not thinking of incinerating them. Other than there's been discussion about this, try to clean up the ash for selling it or something. So. Any other questions? Yeah. The amount of oxidation, does it increase reemissions? Is that what you're saying? Yeah, I think he's probably, I'm sorry, I can't hear you very well. We can get the mic. Apologize. My wife says I need a hearing aid, but I don't believe it. Not yet.
Yeah, have you considered the amount of oxidation air for the scrubber to control that flow rate as part of ORP control?
Yes, and I've seen both sides of that coin. I've been where we've cut our oxidation air where they let me. I said, let's cut it back by half. And they go, okay, that's all we're going to do because you get into limestone blinding. So they were scared to go further. I've seen where we do that and the mercury starts going up. And then there's cases where you can actually reduce the oxidation air because a lot of the scrubbers were just, this is what you're doing, you're putting in way too much anyway. And you can reduce that, and I think there's some data that shows you get some ORP control that way. But I have to see enough data to make me believe it, and I'm not seeing it solid that direction yet.
Have you been able to see a correlation by use of the wet scrubber additives for reduction on the back end in wastewater treatment plants from use of organosulfides for mercury control in water?
There are some definite beneficial side effects, and one of them I noticed, and it's all related to ORP. I mean, that's the key. The key is reduce ORP, and if it does it by itself, it's already there. If you have to force it low with some chemicals, you can get it there. But we have seen that with the lower ORPs, you get like an improvement on selenium speciation. You get maybe, and I've seen 100% selenate. You drop ORP and you get 50%. Well, that 50% selenite is more easily removed than the other. Other than that, I don't know if I've seen any other metals or whatever come out. I'm sure, but and if you're familiar, Nalco has another product called Nalmet, and it's just a precipitant, right? So what we were told is, yeah, you put in this reemissions chemical, and if you're using Nalmet on the water side, you'll use less of it because you're getting some of that metals removal with this other chemical. So I really haven't seen a negative effect with it, and there's some benefits if that's what you're referring to.
We've seen a positive where basically if you're using a organosulfide in the scrubber for mercury removal, you can eliminate the use of it in the back end of the wastewater treatment plant because you're already tying up the mercury in a mercury sulfide. So basically you're supplementing one use from the wastewater treatment plant, removing that into a vessel what was for SO2 removal now is a large wastewater treatment removal vessel.
True.
So really we've seen that once you use an organosulfide or any wet scrubber additive in the scrubber, you can pretty much eliminate by almost 90% the use of, so you're just replacing one sulfide in one different area.
Yeah, and I've asked, and Nalco will tell you that theirs is not an organosulfide, although I think it's semantics, but I'm not one to say. But yeah, there's definitely some benefits that help in that direction.
Add to that, one concern of that is absolutely true. The problem is that how we control our wastewater treatment systems. We're taking grab sample data, sending it off to a lab, getting that data back 3 weeks later. So it's difficult for us on the wastewater treatment side to actually make that change because we have to still kind of cover our butts, so to speak, and make sure we're in compliance. So that benefit definitely exists. We've seen it, Stephen, testing we've done, but it's hard to capitalize that in the wastewater treatment because, like we always say, we're trying to drive, 2 weeks in the rearview mirror. So.
Okay. Well, I thank you all for your attention.